Okay, so to ever move an object, it's simply transform.translate. Now, there's a couple of ways of moving an object. So translating will actually teleport it to the next spot, so it won't collide with objects. So if the move is big enough, it won't actually collide with it. Transform well, getting the physics body and adding a force in a direction will cause it to like actually calculate everything between the point where it got hit to the point where it ends up. So adding force is better. And then also there's a character controller that has a move function that allows you to actually translate everything in between. But for right now, we're just doing basic kind of movement. So translate, it works, but just giving you a fair warning, it's probably the weakest of your options, especially if you're worried about physics. If you're not worried about physics, then translate's great. So spawning a character or doing like a Star Trek where you're just kind of getting beamed down to a certain location, translate works awesome. Of course, if I was doing a Star Trek thing, I think I'd actually change levels because I'd be beaming down to a whole new world. So that would be just changing levels. But you notice the translate takes a vector 3. And we have a vector 3 up here, the right vector. So whenever you type a function, it'll tell you what you need inside of it. Now, it's 1 of 6. So actually, we could do space that's relative to, transform is relative to. We can actually give it an XYZ. I did not know we could do that. That's cool. So it's kind of good to go through these. You can learn new things. And then the XYZ with the space relative float and relative. So this is what's known as an overloaded function. So it's one function, translate, but depending on the variables you pass it, it'll behave differently. So we just need the very basic one, the first one, and you actually don't have to go back to it. This is just kind of comments on how to use the function. But yep, we want the one vector 3. So I'm going to do a right vector. And yeah, go ahead and save that. Now I'm going to warn you, our sprite is going to go away really quickly. Play. Uh-oh. Do I have an error? Actually, let me save this. Make sure I save this. What the heck? Oh, duh. Well, not too exciting of a dog. So this move right gets called once. So it only moved 1 pixel to the right, and we didn't even see it. So actually, I want to take this move right, Command exit out of there, and put it in our update. So start runs only once, update runs continuously. So this should be different. There we go. The lobster dog went way fast. So you notice the control was kind of out of control. It was moving 1 pixel at 60 frames, so it moved 60 pixels per, or 60 units, I guess I should say, per second. So it was flying. If you want to slow things down, what we want to do is use a thing called time.delta time. So before I'm actually using it, I'm going to do debug.log warning time.delta time, just to see what number that is. So time.delta time is actually the amount of time since the last delta, so the last update. When was the last frame? And generally these aren't going to be whole seconds because there's 60 frames per second, so it's going to be about 1/60th it should be, depending on how fast your computer is. So if I press play now, so it's zooming, and you see if I pause, it's a 0.016. So if you multiply that times the 1, you're going to get 0.016. So it's going to only move 0.16 unit each frame, which is a lot slower. Let's try that out. So instead of adding, we're going to do a multiplication. So I'm going to take this line out, the time.delta time, and I'm just going to do times time.delta time. When you do a times of a vector, remember that it's one number and it's being multiplied by all 3 components. So the x is going to be multiplied by the 0.16, the y is going to be multiplied by the 0.16, and the z is going to be multiplied by that exact same number. So whatever this number is, it's going to be multiplied by each of those three components. Let's save that, and let's run it. Oh, there we go. That's a much slower dog. And then if you want to speed it up, you can multiply it by another number, and it's going to do the same thing. It's going to multiply it by 2, so 2 would be twice as fast. 3 would be 3 times. If you want to slow it down even more, you could multiply it by 0.5, or even divide the whole thing by 2. So, yeah, that works pretty well. Now, let's take a look at the dog versus the camera. So, on the sample scene, I'm going to click on my sprite and uncheck my script. So there's no script running at all. If I press play, I should see nothing happening at all. So yeah. Now I'm going to click back on my main camera and re-enable that script. Let's take a look at what happens. So when I put it on my camera, just stop and think about it. What do you think is going to happen? So, you ready? Let's try it out. So you notice the dog's moving to the left, but that's because our camera is moving to the right. So depending on the object that the script is on, it's going to transform that object. And if I look at my scene, you can see my camera is moving to the right. So there's my camera. It's moving to the right as you expect. Now, if we put the script on both of them, I'm going to play it, and I'm actually going to go to scene mode. So you see that the dog is moving to its right, and the camera's moving to its right. So they're both moving to the right, but they're moving in a different direction because of their transformation, how they're currently rotated.